Okay, so we got our heads back from the machine shop, and we're gonna just quickly check them and make sure they did their job. We're gonna use the flat edge again, and make sure that they're within spec. Start out with the 2000s feeler gauge, and it's definitely within spec. 2000s is the thinnest I have, so we can check it in a couple different directions, but certainly appears that they've done a fine job here, as they usually do. Yep, this one's nice and straight. Oops. Okay. That one's good. We'll check the other one quick. You can see I can't get a 2000s feeler gauge underneath the bar.
So you're lifting the bar, putting the gauge under it, and seeing if it'll drag the bar with it.
Exactly. So I know that since the feeler gauge is being dragged, that there's no air between the bar and the head. So they've done a good job here of making these flat again. So we're in good shape there. So we can put them on the motor. Got the heads all ready to go back on. We're going to talk a little bit about head gasket choice right now. Like I said earlier, the reason we're here is because of a poor head gasket choice. I told you about three different possibilities as far as choices that I make now for head gaskets. This is a 6-star head gasket, and they sell only to wholesale and parts houses. They don't sell to the end user, and I am a distributor of theirs. You can actually obtain these from me through Kerry on YouTube if you contact him directly and give him your contact information. I can get back with you, and I can sell these to you. They're very reasonable. These are the ones I'm going to use today, but I'm going to show you what your other choices are. Felpro makes a this is a gasket that fits this application. This is a MLS. It's a multi-layer steel gasket. It looks very, very similar to the 6-star gasket. Construction is almost the same. If you look at them, they're almost identical. The difference being the coating on the gasket. I'm not really even sure what Felpro does for coating on their gaskets, but I know I've had good luck with them, and I've used a lot of them in the past 5-6 months and have had no failure with them. 6-star gaskets, I've done a lot of research, and 6-star gaskets come with a warranty that's unheard of in the business. If a licensed repair facility installs them, they give you a 1-year warranty, and they include towing and labor if they fail. So that's a pretty darn good warranty. So unless I run out of these or they're on back order, unattainable, I'll use a Felpro or a Subaru gasket, but otherwise I use these primarily. The The Subaru gasket actually is made by Victor Renz, and you can buy these. This is a Subaru part number on here, and this is the Subaru OEM head gasket for the single overhead cam engine. And these work fine too. It's a composite gasket versus an MLS steel gasket, so the chances of it failing because of material separation are greater, which is what I don't like about them. I do use them on occasion if a customer requests them, and I do have customers that specifically want Subaru head gaskets, and I'll use them. That's why I stock them. And like I say, if you order them through a Victor Renz distributor, it's an OEM Subaru gasket. Victor Renz is supplying Subaru. So these are your three legitimate choices. Anything else out there, don't even consider. Just going to kind of go over what I did already. Sometimes you'll see corrosion and stuff on the deck of the block that you'll want to reconsider just putting head gaskets in the motor if you don't have a really good clean surface without any imperfections. So we're going to just take some lacquer thinner, clean the deck of the block. These are oil passages right here, so you want to make sure that there's no dirt or anything in those. When you flip this motor upright, any dirt in here will fall into the engine, so you just want to make sure that there's no dirt in here. Likewise, this is an oil feed hole. You want to make sure that there's no dirt sitting inside that hole, because that'll end up inside the engine. What I'm going to do next is something that I've kind of discovered on my own. Sometimes you'll notice that when you tighten these head bolts on a Subaru, the head bolts will creak as you tighten them, and that's because there's a lack of lubrication on the threads. They have a lot of thread, a lot of bolt thread going into the block, and if there's not enough lubrication on those, the bolt will actually creak as you try to tighten it. So what I do is I pre-lube all the bolt holes with oil. I'm filling up every bolt hole with oil right now. And then I'm going to flip the motor upside down and let it run out of those holes. I'm going to let it run for about a minute. We're still going to put some oil on the threads on the bolts when we insert them in the head, but this ensures that there's enough oil deep inside the block, that there's enough lubricant just to make sure that these heads torque upright. So we're going to wait till the oil's just dripping, and then we're going to flip it back over. Okay, so we've let that run for about a minute, minute and a half, and we're just going to flip the block back over. We're going to clean the deck of the block again real quick.
Back with a lacquer thinner.
Yep, more lacquer thinner. Okay, that's good to go. Now we can set the head gasket on here.
Which way does that go on? Does it only go on one way?
It does only go on one way. There's the oil drain backs for the head are on the bottom side of the block, and you'll see that there's slots in the bottom of the gasket. Those line up with the oil drain backs, and then there's one oval hole right here, and it lines up with the oil delivery hole that supplies oil flow to the cylinder head. So that has to be lined up.
There's not a top or a bottom to it?
It doesn't say top or bottom. No, it doesn't. You have to I guess just be smart enough to make sure you line up all the holes.
Okay.
You know, on the other side the gasket will actually just go the opposite direction, but the 6-star will be facing up. So we've got that lined up. Now we're going to put the cylinder head on there. We're going to pick the correct cylinder head. This is the driver's side. So we're going to grab the driver's side cylinder head.
How do you tell them apart?
Well, the driver's side cylinder head has the camshaft position sensor on it. And I'll show you a little bit more about that as I lift it up. I'm going to clean the gasket surface off first.
No, head gaskets don't use any sealant, right?
Nope. You can't really mess this up because the exhaust port faces downward, and if you face the exhaust port downward, if the camshaft's not pointing the camshaft doesn't point to the front of the engine, then you have the wrong cylinder head. So it's pretty simple to distinguish which one goes where. There's a little bit of oil running out of this oil hole, so just wipe it off quick. And we're just going to set it on then. Cylinder head's on. Now this is where we come into a little bit of controversy, is head bolts on Subarus. It is a yield to torque bolt, which means that the bolts stretch, and that's what gives them their holding power. When you look at Subaru's tightening instructions, it tells you to tighten them to a certain amount, and then to stretch the bolt, and then back the bolt off. And I'll go, in fact, I'll tell you what, I'll even read off what they tell you to do. 6-star gives you tightening directions in their package with the head gaskets, and basically what they're telling you to do is follow the same instructions that Subaru gives you. Okay, if you were to use brand new head bolts, you would tighten them to you would follow a tightening sequence, and then you would loosen the bolts up. You would pre-stretch the bolts and then loosen them up. Okay, that's with brand new bolts. If you don't use brand new Subaru bolts, don't replace them, because they're the only ones that I have found that work properly.
So you're saying
I've used aftermarket head bolts, and they yield way too much.
So you're better off reusing your old Subaru bolts than using aftermarket bolts.
Exactly.
Unless you're going to use new Subaru bolts.
Right. And and I can tell because I'm experienced at this. I can tell if these bolts are stretching beyond what their predetermined yield. It's pretty easy to tell as you go through the torque sequence if the bolt is weak, and if it is, I'll replace it. So we're going to reuse them. Every Subaru technician that I know that works at Subaru as a hardline mechanic reuses the bolts. And if they tell you they don't, they're lying. They do. Subaru might say to replace them, but when they do warranty repairs, they reuse them. And 90% of the time, unless there's a problem with corrosion on the bolt threads, they reuse them. So anyway, we're going to reuse them, and we're going to skip the pre-torque spec where we have to stretch the bolts because they're already stretched. They've been used already. and putting oil on the threads and putting oil on underneath the, on top of the washer, underneath the head of the bolt, and dropping them in. There's two different bolts. There's one with a painted head and there's one with a non-painted head. The non-painted head has a bigger washer on it, and those two go to the center. There's two different bolts. So we're going to use a 14 millimeter 12-point socket, and we're gonna just draw these up. Not even snug. We're just bringing them right up against the head. We're not going to tighten them at all. We're just going to take them to where the head is just starting to snug up. And we're going to go through the torque sequence, which is what I'm doing right now. This is the proper torque sequence for a Subaru head. Now we're going to take a half-inch torque wrench, 14 12-point. We're going to set our torque wrench to 11 foot-pounds. And we're going to go through the torque. We're going to go through the sequence, starting at the top. Hear that one already creaking. Hear that creaking?
Yep.
Take the bolt back out.
Why does that bother you so much?
Because you just can't get a good good torque when they're doing that.
So it's not just an unnecessary noise, it's a warning that the torque's not proper? Not good enough?
Sometimes you could take the bolt back out and run it back in, and it'll stop. It'll quit doing that. I'll add a little bit more lubricant to it.
Doesn't that change the order now? Because didn't you start with that one first?
I only went to 11 foot-pounds, which is barely even tightening it.
Okay.
So I'm going to go back and bring that one back to 11. You know, it didn't creak.
No creaking.
Go through the torque sequence. I'm going to go through it again. I'm going to go through the third time. Okay, we brought all 6 bolts to 11 foot-pounds. Now, what we're doing is we're actually following Subaru's guidelines, but we just disregarded the stretching, the first couple of steps that pretty much just entail pre-stretching the bolt, because the bolts have already been pre-stretched. They've already been in a running motor, so they've been stretched already.
Basically, it's a break-in. They've already been broken in.
Exactly.
Okay.
So, okay, so now we're going to tighten the center two to 25 foot-pounds. Okay. Now we're going to go through the torque sequence, and we're going to go through the sequence twice and tighten it up each bolt up a quarter of a turn twice. So we're going to do it in sequence. So we're starting at a right angle, and we're going to turn it exactly a quarter turn. See that creaking? It's not going to go away on that one. That one too.
So you do the quarter turn twice?
Yep. Quarter turn twice.
Well, that's going to suck if you miscount.
Yeah, this is a critical part. You can't do that. So we're done. That hits tight. We're going to go ahead and pre-lube up all the moving parts on the head before we put the valve cover on. These heads have been in and they've been all washed up, so they've washed all the oil and lubrication out of all the moving parts points. So we're just going to lube them up good. Give them a little pre-lube on for startup. We're going to put the spark plug tube grommets on, pushing them on firmly. They should fit nice and snug and they should be real pliable. Just wipe that off nice. I put new gaskets in the valve covers. I cleaned the valve covers up and I inserted new gaskets in here already.
So the valve covers don't use a...
They don't use any sealer either. Flip the valve cover on. We've got new valve cover grommets we're going to put on there too. On the single overhead cam, you got 2 long bolts that go on the top and then the 3 shorter bolts go in the center and the bottom.
Are the 2 long bolts always where the spark plug holes are?
Yep, they're always on the top 2, next to the spark plug holes. Good to go.
Now, do you go back and tighten those up more later, or is that as tight as they go?
It's a shoulder bolt, so they'd only get tightened up. They're about 20 foot-pounds.
And you just...
Probably not even 20. I mean, I tighten them up by feel. I've been doing it a long time. They're probably only 15 foot-pounds.
So now we're repeating the same process on the other side. Let me guess, you're putting oil in the holes where the bolts go to prevent the creaking.
Hopefully to prevent the creaking. Doesn't always work. It certainly reduces it.
It helps, but it doesn't hurt.
I mean, I wish there was a better solution to that, but okay, so we've let that drain. Flip it back over. I see a little bit of gasket material that I missed. That one on. Ready to set this one on? Red ones go to the outside and then non-painted to the inside. Set the torque wrench to 11 foot-pounds. Go through the torque sequence again. Keep going through the torque sequence until we get a till they all hold their torque, which they are now. Okay, just double check the middle ones. Okay, now we're going to reset the torque wrench to 25 foot-pounds and do the center two. These are not creaking. Okay, now we're ready to go through the whole sequence, 2/4 turns. Just like the other side, we're just gonna lube up the rocker assemblies a little bit. Lubing up the roller assemblies. Just a little pre-lube because we had them apart. Put the spark plug tube grommets on, pushing them on firmly, make sure they're all the way in, and keep in mind if these aren't real soft and pliable, don't reuse them, buy new ones. Slipping the valve cover on. Make sure it's on there square. Start tightening them down with a 10mm socket. And we do it incrementally. And we're just snugging these up. Like I say, maybe 10 to 15 foot-pounds. They're not very tight. They're shoulder bolts. We don't want to break them. And I've seen people strip out the heads and I've seen people break them. We're not going to do that here today. These are all done. Okay, we're going to start assembling the timing cover and components right now. We'll start with the small passenger side timing. It's just a small timing cover. It just basically keeps the elements out of the timing cover. There's just 2 bolts in that one. Put that on and tighten it up.
What size socket is that?
10mm socket.
Subarus use a lot of 10mm bolts.
10, 12, 14, 17.
That's it, huh?
Pretty much. Okay, that one's on. We talked a little bit about this one. These inserts have a tendency of breaking, and if the inserts are broken, I would replace it. This one was brand new when I did this motor the last go around, so none of them are broken. This kind of snaps in place. Just snug them up, they don't have to be real tight. We're going to put the left timing pulley on, and they're marked with an L and an R. There is an L on the pulley. And another way to distinguish the left from the right is on the back side of it. These are the triggers for the cam sensor. It's got triggers on the back side. If you look at the right side, it doesn't have those. So this is the left side. We're going to put that on. Again, the right side has a R stamped right on it. Lining up, there's a pin that has to line up with a notch in the camshaft. Pretty self-explanatory. It only lines up one way. And you put that on and hand tighten it. These cam gears are held on with a 17mm bolt. The head of the bolt is a 17mm, and we're going to torque these to 65 foot-pounds. This is the proper tool for holding the cam gear from turning. The only other way you can do it is put the belt on and pull a tensioner and then impact them lightly. But this is the proper way to tighten them. This just sets in there and holds it from spinning while you tighten it. Just holds the cam gear from turning. Tight. Okay, we're going to start putting the balance of the timing components on now. And what we want to do is we want to check each and every pulley before we put them on. These pulleys are very, very critical, and especially when you've got the engine apart, they need to be checked. A lot of people neglect these particular items when they're working on a Subaru engine, and it's probably one of the main failure points in the engine, especially the cogged gear. This is a cogged idler. When you spin it, it should spin smoothly without any noise, and it should spin smooth as silk. And this one is only about 6 months old, so it's in great shape. I'm gonna grab one and show you what a bad one looks like. I'm going to show you a cogged timing gear that is very close to failure. This is one that came out of a running engine, but it probably wouldn't last maybe more than 6 months or another year before major failure. You can see how it continues to spin, and if you listen, you can actually hear the noise. You can hear the noise it makes. There is absolutely no lubrication left in that bearing. Sounds like a roller skate wheel. And I see a lot of engines come to me where somebody has just done a timing belt replacement and not changed this pulley.
How much does that pulley cost?
$30. It's a $30 pulley.
How long do they normally last?
100,000 miles.
So anytime a timing belt should be changed, that pulley should be changed too, in your opinion?
Absolutely. If you change a timing belt, if the timing belt warrants replacement, so does this pulley. In fact, this pulley probably warrants replacement before the timing belt. 9 times out of 10, if somebody brings me a car for a timing belt replacement, this pulley needs to be replaced worse than the timing belt. And 9 times out of 10, if you take it to a shop that's not familiar with Subarus and how they function and operate, they'll replace the timing belt and leave this unserviced. Only to fail. If this pulley fails, it bends all the valves in the engine. So it's foolish not to spend the $30. Even if you have it done at a Subaru dealer, I think they're only $50-$60. I buy the OEM Subaru pulleys for less than $30, but a shop may charge you $50. They might charge you $60 for this bearing. And regardless of the cost, it definitely warrants replacement. This is the one pulley that fails 90% of the time. There are 2 other pulleys. The two right side idler pulleys. These have been replaced. These are OEM Subaru pulleys. Very smooth. I mean, they literally turn smooth as silk. They've been replaced 6 months ago. So all the pulleys on this engine are in great shape, but just to keep in mind that when you're doing a service and you've got the timing cover off, these need to be looked at, very closely. Very important part of the process.
What are you putting on now?
Putting them on. Yep. And put that one on.
Are they the same, or does one have to go in one location and one goes on the other?
These 2 are the same.
Okay.
Actually, from the factory, they had the lower pulley was a single wide bearing, and it had a lip on the back. I'll show you what that looked like. This is what the OEM pulley looked like that came on this engine. It's got a lip on the back side.
I see.
You can also see that the bearing is not nearly as wide. The actual bearing inside there. See how narrow it is? The bearing itself. These last about half as long as these do. This bearing will wear out in half the time that this bearing will. So, and you can replace them. You can put the wider bearing in here.
Does it have a name?
It's just idler bearing.
But I mean, how do you know when you ask for that part at the parts store that you're not going to get the one with the lip on it versus the one with no lip?
I guess it's something that you just have to
inspect it at the time of purchase.
Inspect at the time of purchase.
Okay.
Yeah. I'm not going to put this one on. I'm going to put the cogged one on. We're going to wait and put the lower one on. I'm going to wait a little bit to do that. So we got these 2 on. They spin very nicely. We're going to index the timing marks. This timing mark lines up with the parting line on the head right here. If you see where my finger is, there's a gasket parting line here, and that's where this one lines up to. On this side, there's a notch in the timing cover that this one lines up to. Right there and right there.
So the camera's a little on an angle, but those two are lined up. It's a little hard to tell from this angle.
Yep, they are. The timing belt has 3 timing marks on it. It's got a dotted timing mark with arrows. That one goes on the crankshaft pulley. Then it's got a line on it right here for one of the camshaft pulleys and another one for the other camshaft pulley. Very, very, very easy to put on without messing it up.
I thought a belt could just go anywhere.
It's a timing belt. Everything's got to be timed.
Yeah, but aren't all the grooves in the belt at the same distance? Apparently not.
Subaru's done this to make it almost foolproof. You line the mark up on the belt with the mark on the pulley. I put just a lightweight clamp on it to hold it in place. You can see the timing mark on the pulley, and you can see the timing mark on the belt.
And that lines up with where on the case?
The parting line between the cam retention plate and the head.
Well, those aren't really lined up.
Well, it's not, because if I turn it real hard, it'll line up.
Okay.
But I have to put tension on the belt to get the line up.
And you did the center one first, which is?
Center one is the dotted mark with the arrows. Goes with the timing mark on the oil pump and the timing mark on the crank pulley.
So that little groove right there is the timing mark. That little groove right there is the timing mark. And then this line here.
Lines up with both of those timing marks.
Okay. And then by default, the other one should just line up automatically, right? The third one?
By default.
So there's the mark on the pulley.
And the mark on the belt.
There's the mark on the belt. And where's the mark on the cover?
Right here. A little notch.
Gotcha.
So all the timing marks are lined up right now. We haven't put this lower pulley on yet. We're going to wait until the tensioner on. We're going to put the tensioner on before we put this bottom pulley on.
Now you've got to do something with the tensioner to pre-tension it, right?
Exactly. Got the tensioner in my hand, and we're going to compress the piston. It's an oil charged piston, and we're going to compress it quick and put a pin in there to hold it in place while we put the tensioner on the engine. A brand new tensioner would have the pin in it already, but because we're reusing the tensioner, we're gonna reposition the pin in there. We're just going to tighten it up.
So there's a little pin in there you're pushing in.
Pushing a piston in.
It's a piston, okay.
Piston. It's an oil charged piston.
And when you get it pushed in enough, then that little hole at the top should be lined up with the other hole.
Will line up with the hole in the piston like it does right now. And then I just take it back apart. You can look at it and you can see that it retains the piston in a certain position.
Cool.
Okay. Now while we have everything lined up here, we're gonna set this in place.
So let me see where that goes. Okay.
And we're gonna start it by hand. We're gonna put that bolt in by hand. I see lots of people, because they put this bottom pulley on first, and the belt, and if the belt is brand new, it's so tight that you can't get this in. It's very difficult to get in, and people will put a wrench on here and strip the hole in the back of the retention plate for the tensioner. So
and the belt doesn't need to be tight until the last thing you do.
Right. Once I get all these pulleys, well, I'll put this pulley on now. Now I can actually push the belt up by hand and put this bolt in.
Very clever.
We just leave ourselves a little bit of slack in the belt so we can get this in. Now we're going to tighten all these components up and tighten them to 50 foot-pounds. This is a 14 millimeter socket. We're going to tighten all 4 of them. Double check, make sure all the timing marks are lined up. Take the clamps off, pull the pin. Everything's tensioned. Ready to put the cover on. If this was a manual transmission car, this plate would be bolted on right here at these 2 points on the oil pump. This is a bump. It's called a bump plate.
On the oil pump?
This is the oil pump back here.
Oh, okay.
Right, and there's two bosses that are built into that oil pump, and if it was a manual transmission car, it would come with one of these plates on there, and it would be bolted in, and it would be adjusted so there's about 50 thousandths of clearance between the belt and the plate. You want at least 50 thousandths clearance there. And basically what this plate does is if somebody bumps into your car, if it's a manual transmission and it's in gear, and somebody were to bump into your car, the timing wouldn't jump, because the timing can jump very easily on the crank gear on this particular motor. With an automatic, you don't have to worry about it because there's no direct drive. But with a manual transmission, this is very critical.
And that just tilts and it locks the gear from spinning?
This keeps the belt inserted into the crank
Oh, it keeps
gear.
the belt in the, okay, I see what you're saying.
In the crank gear.
So the belt can't rise
It can't rise and slip.
and slip out of the teeth.
Exactly. All it does is there's only a 50 thousandths clearance. So if this engine gets jolted, it doesn't allow the belt to rise up out of the teeth of the gear and spin. So this is only used on manual transmission cars.
And this car is obviously going into an automatic transmission.
Exactly. So we
Okay.
don't put one on there.
So then the last part now for the timing is the timing cover?
Timing cover goes on now.
All right. And we saved all the bolts.
We sure did. And these timing covers are notorious for breaking. Lots of people pry on them to get the harmonic balancer off, and they break them.
Yeah, you mentioned that when you were taking the balancer off that you took your time and you didn't want to put any pressure on that plastic because it's plastic. It'll crack.
Exactly. And these are about $45 if you have to replace it. 45.
Do you know if there's an
$50.
aftermarket metal one?
Nope. Nobody makes any there's not even an aftermarket plastic one available.
Wow.
You have to buy this at Subaru.
I wonder why.
Yep. There you're at their mercy. I replace this timing cover on almost every engine I rebuild because they're almost always broken.
And are you always replacing them with new, or do you just get them out of junkyards?
If you can find one at a junkyard, it'd be a miracle. They're not available.
Those are still 12s,
These are 10s.
10s,
Yep.
10 millimeter. How many bolts in total hold that on?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 hold this section of it on, and then there's 3 that hold the other smaller cover on.
And those are just hand tight.
Sure.
How tight you make those bolts? You don't want to crack the plastic, right?
No, they're shoulder bolts, so they won't crack the plastic, but I just snug them up. They don't have to be real tight. You don't want to strip them or break them. Not to be real tight at all.
And that little last cover there. Why does that come off separately? Why isn't that all just one piece?
Good question. That's a legitimate question.
No good reason
You'll
you
have
could
to
think
ask
of?
Subaru that one.
Interesting. Unless it has something to do with expansion.
On the earlier single overhead cam 2.2s, they actually had a center cover and then 2 side covers.
Yeah, at least it would be the same on both sides.
Right.
It's just weird, it's just on that one side.
When they redesigned the 2.5 single overhead cam engine, they went to it's called the panhead motor, and they make a 2.2 that's just like this. Or yeah, they started that in '99 at 2.2. Engine looks exactly the same, but it's a smaller displacement. They made them in '99 and into the 2000s. So we're going to put the harmonic balancer on now.
So you got to take that bolt back out. I guess that keeps you from losing the bolt if you just leave it in there, huh?
Yep. I'm going to put a little bit of grease. Put a little bit of grease in here so it. Next guy has to pull it off. It's easier. We're gonna line. There's a keyway. We're gonna on the bottom, and we're gonna line up the keyway on the bottom on this, and slide it in. See? Crank tool. These 4 are used on a 2.2 harmonic balancer, and these 4 are used on a 2.5. They have a different configuration. We're going to set the feeler or the torque wrench to 125 foot-pounds.
That's a tight one.
Yeah. Don't want it to come loose. Makes a mess of things if it comes loose. If it comes loose, it tears up the end of the crankshaft and the motor's junk. And I see them come loose all the time. People do timing services in the car, and they don't have the proper tool to tighten this bolt up. Sometimes you'll see them with Loctite on them. But this is the correct way to do it. These are specialty wrenches that are available for holding camshafts and crankshafts for Subarus. This one right here is for to hold STI camshaft sprockets. This one right here is for a dual overhead cam 2.5 camshaft sprocket. This one right here is for this motor for holding the steel gears on the 2.5 single overhead cam engine. And this one's for holding the crankshaft. These tools are available. There's a couple of different eBay stores that sell them. There's an outfit called JATmotorsports.com that sells these. That's where I bought mine from.
I'll make sure we put a link to that in the video notes below the video.
Yep, jatmotorsports.com. These range between $45 and $50 each. But if you're going to do any amount of work on a Subaru engine, they're a must. I mean, I worked on Subarus for a while without these, and I'll tell you what, since I bought them, it has made my life so much easier. Especially if you're doing a timing belt service in the car and you need to remove the cam gears or the crankshaft harmonic balancer. This tool makes it so easy to get it loose and take it back and put it back on and get it torqued to the correct spec. So it's worth the investment. $200. I paid, with shipping, I think I paid $225 for all 4 of these. We're going to insert the dipstick real quick here. Put a little bit of oil on the O-rings before we tap it in place. Just feed it in through next to the water crossover tube. Right like that. We're going to go down here and we're going to see where it goes into the oil pan right here. Just, you can feel it with your fingers. Just line it up. There we go. Just pushes in. Snaps right in. And then we're going to put the retention bolt in up on top. Let me just pick this mess up quick.